The rising tide, floods and their impact. When you hear of floods, what thoughts come to mind? Flooded streets and homes, downed power lines, devastation and death, huge costs? It is all the above. In the United States alone, floods cost billions of dollars every year in damages and recovery efforts. Between 1980 and 2022, the U.S. experienced numerous billion-dollar weather disasters, with flooding being a significant contributor. In 2022 alone, there were 18 separate weather events that each resulted in at least $1 billion in damages. In December 2023, heavy rainfall caused significant flooding across Florida and the Carolinas. This storm alone resulted in $1.3 billion in damages and widespread power outages affecting hundreds of thousands. The cumulative economic losses from these events have exceeded $1 trillion since 1980, with hurricanes contributing significantly to this total due to their associated flooding impacts. Additionally, floods are becoming more frequent and severe, impacting more regions than ever. The average time between billion-dollar disasters has decreased significantly from 82 days in the 1980s to 18 days from 2017 to 2022. This trend highlights an increasing frequency of severe weather events, including floods. Around the world, many people are equally affected by floods, often losing their homes, livelihoods, and communities. In Asia, tsunamis and typhoons are frequent occurrences. The resulting floods cause widespread damage and displacement, resulting in a devastating impact on communities with long-term consequences. To mitigate these impacts, we need better ways to predict floods and implement effective prevention strategies. However, predicting floods is difficult and complex. Weather patterns can change quickly and unpredictably. Traditional methods are only sometimes accurate, often leading to errors. This makes it hard to warn people on time, putting lives at risk. We need more advanced ways to predict these events using cutting-edge technology and innovative approaches. This is where artificial intelligence and data science come in. Success stories of AI-powered flood prediction. Several flood prediction systems leverage artificial intelligence, AI, and data science to enhance forecasting accuracy and timeliness. Here are the primary systems currently in use, along with specific flood events where they have been successfully implemented and the quantifiable improvements they facilitated. The first system is Google's Flood Forecasting System. Launched in 2018, this system initially focused on regions like India's Ganges-Brahmaputra basin, prone to severe flooding. As of 2023, it provides real-time river forecasts for over 1,800 sites across 80 countries, covering a population of approximately 460 million people. The system employs machine learning models to analyze rainfall data from various sources, including satellites and ground stations, transforming hydrologic models into streamflow forecasts and inundation predictions. It achieved spectacular results across the board. It extended the reliability of flood forecasts from 0 to 5 days in advance, particularly in regions lacking robust data infrastructure. It powered early warning systems, reducing flood-related fatalities by around 40% and having economic impacts in vulnerable regions. Second system, AI-driven automated flood detection. These systems apply deep learning architectures like ResNet-UNet, are based on satellite data, and are fully automated. They have been operationalized during multiple hurricane-driven floods in the U.S. They were also used to great effect in Mozambique, where they enabled timely aid distribution and enhanced community resilience. They resulted in time savings of up to 80% compared to traditional manual or semi-automated methods for flood extent mapping. They achieved high detection accuracy rates of up to 99%, significantly enhancing the reliability of flood risk assessments and response strategies. The third system is the Flood Analytics Information System, or FAIS. FAIS integrates crowd intelligence and machine learning for real-time flood warnings. It uses geotagged social media data alongside river gauge readings to identify at-risk locations dynamically. It updates prioritized locations every 15 minutes based on real-time river conditions, improving situational awareness during floods. FAIS was beta tested effectively during hurricane-driven floods in the United States, demonstrating its capability to enhance decision-making processes for emergency management. These examples illustrate how AI and data science significantly enhance flood prediction capabilities. By improving forecasting accuracy, extending lead times for warnings, and automating detection processes, these technologies play a crucial role in mitigating the impacts of flooding on communities worldwide. How artificial intelligence predicts floods. AI to the rescue. How artificial intelligence helps predict floods, plan and deliver disaster response. Artificial intelligence helps in the following ways. 1. Enhanced flood prediction. Systems like Google's flood forecasting system mentioned above provide accurate flood forecasts up to 7 days in advance, covering regions where traditional forecasting methods are less effective due to inadequate data infrastructure. They also enable automated flood detection using satellite data, resulting in time savings of up to 80% compared to traditional methods and high accuracy rates, up to 99% in identifying flooded areas. 2. Optimized resource allocation. AI algorithms help in disaster response planning by enabling authorities to determine optimal evacuation routes and identify safe zones during floods. They also help plan resilient infrastructure such as flood-resistant buildings and drainage systems, thereby minimizing future flood risks. They do so by analyzing topography, land use, and historical flood data. 3. Community engagement and education. AI-driven chatbots and platforms disseminate crucial information in real time about flood risks and preparedness measures to communities. These tools provide real-time updates during flooding events, helping residents make informed decisions about evacuations and safety. They also enhance collaboration with NGOs serving the local population. 4. Post-flood damage assessment. After a flood event, AI helps assess damages by quickly analyzing aerial imagery of the flooded areas. Models like Dahitra classify building damages based on satellite images taken before and after disasters, allowing for faster recovery planning and resource allocation. In a nutshell, AI's application in flood preparedness and response leads to more accurate predictions, efficient resource management, and enhanced community engagement. These advancements improve immediate responses during flooding events and contribute to long-term resilience by informing infrastructure development and disaster planning efforts. By leveraging AI technologies, communities can better prepare for and respond to the increasing frequency and severity of floods exacerbated by climate change. Challenges in flood prediction: the struggle to stay ahead. While AI and data science have made significant strides in flood prediction and management, they also face several limitations. First, let's talk about data limitations. Scarcity of reliable data is a major issue. Many areas, especially in developing countries, lack essential hydrological data such as streamflow gauges. Only about 1% of the world's watersheds have these gauges, which hampers the accuracy of AI models that rely on historical data for training and validation. Next, there's the quality of data. AI models' performance heavily depends on the quality and quantity of data used for training. Inaccurate or incomplete datasets can lead to poor predictions and unreliable flood forecasts. Another challenge is model interpretability. Many AI models, particularly deep learning algorithms, operate as black boxes, making it difficult to interpret how they arrive at specific predictions. This lack of transparency can hinder trust among stakeholders who need to make critical decisions based on these predictions. Then, we have generalization issues. Overfitting is a problem where AI models trained on specific datasets may not generalize well to new or unseen scenarios, particularly in ungauged basins where historical data is limited. This can result in inaccurate flood predictions when applied to different geographical contexts. Adaptability to changing conditions is another concern. While AI models can learn from historical data, they may struggle to adapt quickly to changing environmental conditions or extreme weather patterns exacerbated by climate change. Computational challenges are also significant. Some AI models require substantial computational resources for training and operation, which can be a barrier to implementation in resource-constrained settings. Additionally, real-time processing limitations exist. Although AI can process large datasets quickly, real-time integration of diverse data sources, such as satellite imagery and weather forecasts, remains a challenge that can affect the timeliness of flood warnings. Lastly, there's the issue of flash flood prediction. Flash floods occur quickly after intense rainfall, often within hours. Current AI models may not provide timely predictions due to their reliance on historical data and longer lead times for training. So, while AI and data science offer promising advancements in flood prediction and management, addressing these limitations is crucial for improving their effectiveness. Enhancing data availability, improving model interpretability, ensuring adaptability to changing conditions, and optimizing computational efficiency are essential steps toward more reliable and actionable flood forecasting systems. Scientists are working to overcome these challenges. With more research, AI can become even better. The future of flood management, a future fortified by AI. The future of flood management will see AI playing an even bigger role. As technology advances, so will AI's capabilities. We can expect more accurate and timely flood predictions, which will help us build resilient communities. AI-powered early warning systems will save lives and reduce the economic impact of floods. In conclusion, AI is a game-changer in flood prediction. It provides us with precise and timely data, enabling communities to prepare and respond more effectively. It helps us understand and manage flood risks better. By simulating various scenarios, AI allows us to predict potential outcomes and take preventive measures. While challenges remain, the future looks promising. Continuous advancements in AI technology are paving the way for more accurate and reliable predictions. What do you think about AI's role in flood prediction? Your insights and opinions are valuable to us. Share your thoughts in the comments below. Thank you for watching. We appreciate your engagement and look forward to your feedback.